Up on the screen here, an example of a pretty typical SAT maths question you should see. This is a no calculator question for those of you familiar with the SAT. I just want to go through a simple strategy and actually a couple different ways you can look at this question so you can apply it when you do end up taking the SAT. So this question involves a typical linear relationship, and you see a lot of these on the SAT. So part of the challenge with the test is you might be familiar with some of the topics they test on, but they present them in new and different ways, so they may be a little bit confusing when we first read them. So I want to go through actually a couple different approaches we can take here. So as soon as we see this equation here, this should remind everyone of the standard equation of a line, y equals mx plus b. So in this case, our y is going to be n, and our x is going to be t. So everyone should be familiar, if you've taken an algebra class, with how to actually calculate slope. So the m is the slope, and that's change in y over change in x. So I'm going to put y2 minus y1 over x2 minus x1. So in this case, because my n is y and my x is t, I would just be thinking in terms of those. So now, all right, how can I apply this to the question here? So first of all, let's take a quick read through the paragraph below this equation. So the equation above is used to model the relationship between the number of cups n of hot chocolate sold per day in a coffee shop and the average daily temperature T in degrees Fahrenheit. According to the model, what is the meaning of the 3 in the equation? Okay, and basically all these choices were not, it doesn't seem like we're actually doing calculations here. All these choices are just statements. For every increase of this, you have a certain increase or decrease of that. So I can actually just go through and test these based on the definition of the slope. So what usually happens is people are very quick to notice this -3 in front of the t, and they see a choice that mentions a decrease of 3 degrees. So that association looks pretty good, a -3, decrease of 3 degrees, especially because it's right next to the temperature. Because that's one of the most commonly picked choices, I just want to test this out using our slope formula. So my decrease of 3 degrees, that would be the change in x. So I'm going to put a difference of 3. I don't have two values here, but I know my change is going to be 3, and it's a decrease. So I put -3 on the bottom. And again, that's just coming from this equation here. It says 1 more cup of hot chocolate will be sold, so that's going to be a +1 on the top. So this gives me -1/3. It would imply a slope of -1/3. But we can see we don't actually have that in the equation. The slope should be -3 because that's the number in front of our x here. So this actually doesn't work. Now I can try out the rest of the choices, but I will point out that the SAT will always use realistic scenarios. So when we see choices that imply an increase in temperature would result in more cups of hot chocolate being sold, it's pretty safe to eliminate those right off the bat. If you wanted, you could test it out the same way and see that the slope wouldn't give us the right result either. So then we can finally test out choice D, and for our decrease of 1 degree Fahrenheit, that's going to be a -1 on the bottom. 3 more cups of hot chocolate, that would be a +3 on top, and this indeed does give us the -3 we were looking for. I'm going to go over one other quick way you can do this, and perhaps a more practical way for a lot of students, is just try out numbers. As I mentioned, this is a no calculator question, but what happens if we use some simple numbers and we see what happens when the temperature goes down from 3 to 0? And again, I'm essentially testing out choice B because that's the most commonly picked choice for this question. So if I try a t value of 3, it would involve a little bit of arithmetic, but it's going to be 456 minus 9, and that gives me 447. Okay, so that's our n value. Now, so I'm just going to put t equals 3 here, and then when we would try out t equals 0, because that would represent a decrease of 3, that would give us 456 minus 0, so that's just 456. So we actually saw an increase of 9 cups. So again, that would quickly tell us that B can't be right, and it would support choice D once again, that for every decrease of 1, the number of cups goes up by 3, because we went down by a temperature of 3 degrees, number of cups went up by 9. You could try going from 1 to 0 just to see that 3-cup increase if you wanted. Okay, so let's try one more example like that just to see how it applies to any similar question that gives you this kind of linear relationship. In this one, we have a relationship between area and perimeter. Looks very similar to the last one. They're asking for something a little bit different, at least the way it's asked, but it's essentially the same exact concept. So I can use either method from the previous question. I'm just going to go through it using the slope definition. I'll leave it up to you if you want to try putting in numbers as well. So in this case, it's asking how many feet will the perimeter of the fountain increase for each additional square foot of the area. So again, I know my slope is, it's change in y over change in x, so the triangle for delta, and in this case it's going to be the change in a over the change in p. So a is my y, p is my x, and I need my slope to end up as 4 because that's the number in front of the p. So it already says we're only increasing the area by 1. So I'm going to put a 1 on top. That's our change in area. Then I'm going to I'll just put an x for the change in p because that's what I want to figure out. That's what's asking how many feet does the perimeter need to increase. So I know this should equal 4. So now I have a pretty simple equation. Just multiply both sides by x, divide by 4, and we get 1/4. Once again, you can test this out using numbers. I would recommend plugging in a simple number for p, figuring out what a has to be based on that, and then add 1 foot to the area and get the new value of p. Okay, so that's a very typical linear relationship question on the SAT math section, and I hope you found it useful and can apply it when you do take the SAT or just in any general algebra class. So just quickly want to mention a few things we have going on. Due to the difficult times a lot of students are having with school closed, we are giving a 50% off discount to our self-paced program. So you can find more information about that on our website, as well as some live interactive classes just like this starting this weekend for the ACT. Those are 2 hours each, and again, you can check those out on our website, and we'll post more information about those on our Facebook page as well. Okay, so thanks everyone for watching today, and hope to see you back tomorrow.